Okay, so on example 4, this time we're given the similarity ratio. Find the ratio of the perimeters and the ratio of the areas. So we already know, so we just don't have a picture is all. It's the same thing we've been doing. We already know that the side-to-side ratio, in other words, what's called the similarity ratio, they tell us is 3 to 1. And so the ratio of the perimeters, the perimeter ratio, is the same stinking thing. There's nothing to calculate. It's also going to reduce to be 3 to 1, whatever those perimeters are. When you put them one over another and reduce it, it's going to be 3 to 1. And so then for the ratio of the areas, so this one was given to us, then we had to find number 2 here, and then we also have to find number 3, the area of one figure compared to the area of another figure. In other words, the area ratio. We don't know what those areas are, but we know whatever the ratio of one over another is, we know it will reduce to 3 squared to 1 squared. So that's 9 to 1. And that's always the case. The first two are always equal, and this one's always the side squared, right? Okay, so pause the video and you try this second one, and we'll come back and take a look together. Ready? You try. Okay, so just like before, they gave us the similarity ratio that was given to us. The perimeter ratio is always the exact same number. There's nothing to compute or to calculate. And then our areas ratio is always our side ratios just squared. So if I take that 2 to 3 and I square the 2 and square the 3, then that gives me my area ratios of 4 to 9. So those are my answers, 2 to 3 and 4 to 9. All right, let's look at example 5. Now this gets pretty tricky. It says find the values of x and y when the smaller triangle here has the given area. Okay, so what we have here, let's look. We have a big triangle. We know the side lengths of it are 12 and 16. And we have a little triangle. We don't know x. We don't know y. All we know is that the area of this guy is equal to 6. And we don't at first glance know the area of the yellow triangle, but it looks like this is the height and this is the base, so we could figure that out. So 1/2 base times height for a triangle, 1/2 times 16 times 12 comes out to be 96. So here's what we do know. We know the area of both triangles. We know both side lengths of the yellow triangle. The only thing we don't know is x and y. So let's fill in a formula that has some information in it. Let's fill in what we do know. What we do know is that the area to area ratio, I'm going to do the big one on top, why not, is 96 to 6. So let's go ahead and reduce that just to make our lives easier. That's 16 to 1. Okay, now I know that this is equal to the side-to-side ratio squared. So if I can work backwards to figure out what that side-to-side ratio was originally, then I would have enough information to solve this problem. So if my square roots and my squares cancel out, that's how I undo a square, then what number times itself was 16 and what number times itself was 1? That's the same thing as the square root of, right? So the side-to-side ratio would be equal to the square root of 16, which is 4, square root of 1, which is 1. So what does that mean, Miss Benton? Well, that means that this could be like 4 and 1. It's not, literally, but it would, whatever it is for the hypotenuses, it would reduce to 4 to 1. So that's really helpful to know, because now that I know that the ratio of yellow to blue is 4 to 1, now I can use that to find the missing values for x and y. So this was all just work to figure out the side-to-side ratio. So now let's solve for x, and then we're going to solve for y. So it's a lot of work here. So we know 4:1 is the ratio of the day, and that would be the same as the matchy-matchy side of 12:x. So, and down here for y, that would be the same as 16:y. So from here, all we have to do is cross multiply to solve these two problems. Or if you want to use your proportional reasoning, we know that this is times 3, so this would be times 3. You can also cross multiply. Either way, you get x to be 3. And on this one, if you want to use your proportional reasoning, this would be times 4 and times 4, so y would be 4. If you want to cross multiply to solve, you can. Okay, so what I want you to do is pause the video, try the U-try, and then come back and see how you did. Okay, so just to orient you to what I've got here, here's everything to the right of this is the U-try here. So what we still know is that the area of this big triangle is 96. Found that from 1/2 base times height. They gave us that the area of the little triangle is 16, and we know that side squared compared to side squared equals area. So I did my 96 compared to 16, and then I went ahead and reduced my fractions. Now this is where it gets interesting. Because when I square root to get this by itself, the square root and the squares cancel, and I get side compared to side is equal to 6 doesn't square root nicely. So is equal to the square root of 6. Square root of 1 is 1, so that part works out. But now we've got this yucky ratio to work with for our side-to-side ratio. But that's fine. We can do it. So we got to solve for x, and we got to solve for y. So to solve for x, we're going to say square root 6 is to 1. Let's do our matchy-matchy sides, 12 is to x. And to set up our proportion for y, square root 6 is to 1 is our side-to-side ratio, as 16 is to y. So when we cross multiply this, you're going to have 12 equals square root 6x. Then to get x by itself, we have to divide both sides by square root 6. So this becomes 12 over square root 6 equals x. But oh wait, we can't have a square root in the bottom of a fraction, so we have to rationalize. We have to multiply the top and the bottom by square root 6. So we get 12 square root 6 over 6, which simplifies. 6 goes into 12 2 times to 2 square root 6. Whew, how's that for an answer for x? Now let's look at y. Same scenario, cross multiply. So you get square root 6 times y equals 16. We want to get y by itself. We want to solve this equation we just created. So we divide both sides by square root 6. But oh no, we can't have square root 6 in the bottom of a fraction. So we rationalize. We multiply the top and the bottom by square root 6. And that gives us 16 times the square root of 6 for the numerator over 6 for the denominator, which for our final answer, this is going to reduce 16 over 6 to 8 square root 3 over 2. And that, my friends, is your answer for x and y. Correction, that's 8 square root 3 over 3. Oops.